In this lesson, we look at surface areas of prisms. You'll learn how to find lateral areas of prisms and surface areas of prisms. How do brick masons know how many bricks to order for a project? The owner of a house wants to build a new unattached brick garage. The sides of the garage will be brick. The brick mason has to estimate the number of bricks needed to complete the project. Most buildings are prisms or combinations of prisms. The garage shown above could be separated into a rectangular prism and a rectangular pyramid. Prisms have the following characteristics. The bases are congruent and in parallel planes. The rectangular faces that are not bases are called lateral faces. The lateral faces intersect at lateral edges. Lateral edges are parallel segments. A segment perpendicular to the bases with an endpoint in each plane is called an altitude. And it could be here or they could have used the lateral edge. The height of a prism is the length of the altitude. A prism with lateral edges that are also altitudes is called a right prism. If a lateral edge is not perpendicular to the bases, then it is an oblique prism. The lateral area, and they use capital L to stand for that, is the sum of the areas of all of the lateral faces. So they all happen to be rectangles, and they all happen to have a common length of h. The widths are all different. So they factored out the h from all their area formulas and came up with this simple formula for lateral area, which is perimeter of our base, capital P, times h, height or altitude of our prism. From this point on, you can assume that solids are right solids. If the solid is oblique, they'll tell you. If a right prism has a lateral height of L square units, a height of h units, and each base has a perimeter of p units, then L equals perimeter of base times height. So we're going to start off by finding the lateral area of the regular hexagonal prism. Keyword there was regular. So since the bases are regular, it means that all the sides are 5. So to get the perimeter of the base, all we have to do is take 6 times 5, so 30. I added some subscripts for my sake. LA for lateral area equals perimeter of base, so I put P sub B times height. So the perimeter of our base is 30 times our height was 12, and we are done. 30 times 12 is 360, and our units were centimeters, so it's going to be centimeters squared now that it's area. So if we want to step up and do the entire surface area, all we need to do is add our bases. So by nature, the bases have to be congruent, so we just took our lateral area plus 2 areas of our bases. Now the bases of a right prism are always congruent, but the faces are not necessarily. Now just for fun, because this is a rectangular prism, I'm going to do this one 2 different ways. You can just write down one, but just for fun. Okay, so I'm going to first assume that the base is the bottom. So my base would be 6 by 12. So my whole lateral area would be, perimeter of my base would be 24 plus 12, so 36 times my height is currently 6. And then I need plus 2 area of the base. 6 times 12 is 72. And when we add 216 and 144, I get 360, and it was square centimeters. Now just for fun, I'm going to do it again using the square as my base. Okay, so this time my base is going to have a perimeter of 6 times 4, so 24. And then my height is going to be that other dimension, so times 12, plus 2, the area of my base would be 6 times 6 is 36. So when I multiply 12 times 24 and add 2 times 36 is 72, I'm going to get 360. Oh, who knew? Okay. I just thought that was kind of interesting that we could do the problem two completely different ways and get the same answer just depending on what you decide your base is. So here I have my base being the front, and here I had the base being the bottom, and then the height was that 6. Yeah, it's only fair that we look at a triangular prism as well instead of just sticking to rectangular ones. And I changed my formula a little bit. I wrote out the lateral area as perimeter base times height, plus 2 capital B is what most places use for area of base. To get my area of the base, or perimeter of the base, I need to know the length of the legs of that triangle. And I said legs because it's going to be an isosceles triangle. Well, and happens to be, I can see this is going to go really well because we've got our classic half of 12 is 6. So there's my 3 times 2, 4 times 2. So 5 times 2 is going to be 10. You could always use Pythagorean theorem, but I thought that was a nice little happenstance. It's nice to take advantage of those. So our surface area is going to equal, perimeter of base is going to be 20 plus 12, so 32, times the height is the other dimension, so that won't work. 10 plus 2, area of our base, it's a triangle, so it's going to be 1/2. Base of the triangle is 12, times the height of the triangle is 8. So I've got 320 plus half times 2, that worked out well, plus 12 times 8 is 96. So 320 plus 96 is 416, and they didn't give us units. Rats. A solid block of marble will be used for a sculpture. If the block is 3 feet wide, 4 feet long, and 9.5 feet high, find the surface area of the block. And we have already done one twice, so I'm not going to make you do that again. So I'm just going to let the top and bottom be our bases. So the perimeter base, 3 plus 4 plus 3 plus 4 is going to be 7 times 2 is 14, times my height is 9.5, plus 2 times the area of my base, 3 times 4 is 12. And if we add 133 plus 24, we get a total surface area of 157, and it was in feet. The lateral faces of a prism are the faces that are not the bases of the prism. The lateral surface area of a right prism is the perimeter of a base of the prism times the height or altitude of the prism.